Hello, welcome back. So this is the first of many sections on data structures. The first one we're going to talk about is called the singly linked list. We also have a doubly linked list. We'll see that later. We're starting here. So a quick preface, a warning, a note. If you're unfamiliar with the ES 2015 class keyword, JavaScript's approximation or syntactic sugar to sort of look like traditional object-oriented programming. If you've never seen that before, or you want to refresh your memory on it, take a look at the previous section. I think a lot of students may have jumped to this section. If you did, I would check that out if you're not familiar with how it works. It's a quick little section. And the reason is that we're going to use that class keyword in pretty much every data structure we make, or every data structure we create. We'll define our own JavaScript class. We're going to make a singly linked list class in this section and do the same thing for graphs and every other structure we see. Okay, so quickly, our objectives. We want to explain what the heck a singly linked list is. We're also going to compare it to the list structure we already know, the built-in array. We use it all the time. So that stores a list of data. What's the difference? And then the bulk of this section will be devoted to actually defining our linked list class and adding in a bunch of methods, a lot of functionality to push things into it, or to pop things, or to search and traverse, or to delete things, to all sorts of things. So that's what we're going to do in this section. Okay, so let's start with a definition. What is a linked list? So it's a data structure. It stores whatever sort of data you want, strings, numbers, it doesn't matter. And it's ordered. It's a list of data, just like an array, but there's a really big distinction. In an array, each item is mapped, it's indexed with a number. So I can get the fifth item, the sixth item, and anytime we add something in, it gets an index that is mapped to its position. A linked list, on the other hand, just consists of a bunch of elements with no indices who are just pointing to the next element. Sort of like a bunch of train cars connected, where one car connects to the next one, and that one connects to the next one, but there is no index that we use to access things. We can't say, give me the fifth thing. We have to start at the first one, and then move to the second one, move to the third one, move to the fourth, and then move to the fifth. So just some terminology here. I'm going to show you a diagram in just a second. But we say that each element is a node. So a linked list consists of a bunch of nodes. A node stores a piece of data, like a string or a number, but it also references the next node. Or if it's at the very end, there is no next node, it references null. And then three properties we keep track of. The head is the beginning of the linked list. The tail is the end. So we don't keep track of every single item in the middle. We just keep track of the head. And from the head, we can figure out the next one. And from there, we can figure out the next one all the way until the end. And then also we keep track of the length to make things easier. So here's sort of a diagram of what a linked list looks like. Notice there is no index, so we don't say this is the 0th, the first, the second, the third. If we want to access something from this list, we start at the beginning. If we want the second to last item, we have to start here and ask for the next item, which gives us 6. And we have to ask for the next item, which finally gives us the second to last item. So a linked list is just a bunch of nodes pointing to other nodes. So one node points to the next one, points to the next one, sort of like a chain of elephants. Back before they banned elephants at the circus in the US, they would grab each other's tails with their noses and walk in a line. I kind of like to think of it as a skyscraper that has no elevators. So in an array, there's elevators. You could say, take me to the 5th floor, and it takes you right there. If you're in a linked list, there's only stairs, and each floor is connected to the next one by a set of stairs. So to get to the 5th floor, we have to start at the first one, take the stairs to the second, then go up to the third, then to the fourth, and then we get to the 5th. I don't know if that's a great analogy or not. By the way, the terminology singly linked list comes from the fact that each node is only connected one directionally to the next node. A doubly linked list, which we'll get to, so don't worry about it right now, also has a connection pointing back to the previous node. And we'll talk about the pros and cons of that later on. So here's a visualization on Visualgo. I never know how to say this. It's a great website though, and it's going to be very useful here. So this is a linked list where each node just contains a number. Remember, it could be whatever we want. We could have, I don't know, strings. We could have we could have an array in each one. It doesn't matter. And they all just point to the next item, except for the last one. There's nothing after it. And let's say that we're going to, I don't know, insert something. Actually, let's start with searching for something. So if we want to search for, let's say 43 in this linked list, we have to start at the beginning and check the next, then the next, then the next, then the next, and then we find 43. Okay? If we wanted to insert something into here, if we want to insert something in the middle, No, that's this one. Let's say at position 4, we want to insert the number 90. We have to start at the beginning, then move down to the next, keep going until we get to the correct spot, and then we insert it in. Now, the actual process of inserting we'll come back to. We're going to write our own insert functions. It's pretty easy though, especially if we're inserting, to the beginning or the end. All we have to do, let's say, to insert it at the very beginning is just make this the new head and have it point to the old head. And all of a sudden, we're in business. Unlike an array where we would have to, well, we don't do this, but in an array, every single item would have to be re-indexed to get a new position number. Okay, so we're going to come back to this and spend a lot of time sort of walking through this as we build our own methods. But let's wrap up with a comparison with arrays. So linked lists don't have indices or indexes, I guess I wrote. I think it's indices. They have no number that corresponds to each item. Instead, we just have the head pointer, which is just a variable that says this is the beginning of the list. And we have a tail. You actually don't have to have a tail. It just makes it easier if you're trying to add to the end. But we have to have that head. That's the beginning. And then we can just move to the next, and to the next, and to the next, until we find what we're looking for, or we insert something. Unlike an array, there's no positional, there's no indices. So each node is connected with a next pointer. What this means, random access is not allowed. So random access means I can't just ask for the 10th item and get it immediately. We have to traverse from the beginning all the way to the 10th item. Just like the analogy I explained with the skyscraper, if you have an array, you get an elevator straight to the 10th floor. If you have a linked list, you walk all the way up to the 10th floor. However, one of the things that linked lists are good at is insertion and deletion. So because arrays are indexed, if we insert something at the beginning or in the middle, we've already talked about this, it has this cascade ripple effect. Everything has to be re-indexed. In a linked list, that's not the case. And we'll get into this further. We'll talk about big O of certain operations throughout the section. But just know that that's one of the reasons, or really the main reason you would want to use a linked list, is if you really care about insertion and deletion. Especially if you're working with really, really long pieces of data, or not pieces of data, with a long data set, lots of information, and you don't need random access, you just need to store it in a list, well, you might want to use a linked list. But we'll come back to this. Remember, a lot of this right now is just going to be very sort of theoretical and conceptual. Don't get too caught up on, why would I use this if we already have an array? Because at the end of the day, you could use an array for all of this. But there are advantages to linked lists, and we'll expand on that. Anyway, in the next video, we're going to define our linked list class and add our first method in. So that's coming up next.